Hi, I'm Terry Klinker. In our next several sections, we're going to be looking at the use of spreadsheets in modeling. Now, the important thing to understand is everything we did earlier, the simple indifference points, break-even points, the indifference tables, the graphs, the decision trees, these are all models. These are models from which you can take a look at it and say, okay, for every value of P, for every probability that we have strong demand, we can decide which condos we were going to invest in. What we're going to talk about now is systems that are more complex. It's easy to do things that by hand if you have a limited number of options, a limited number of outcomes. But as it gets more complex, can we do it by hand? Certainly. But it takes a lot more time, takes a lot more algebra, and quite truthfully, we have spreadsheets and other tools that will allow us to do it much more quickly, much more easily, much more efficiently. So what we look at here is, we're going to use spreadsheets for a lot of these. And we're going to use spreadsheets right out of Excel. Now, why would we use spreadsheets? Well, we need to build models that represent reality. We need to build models as managers that will represent business problems. Obviously, you use computers for all kinds of things. Well, using computers to do all of the repetitive tasks of a model goes right along with all the other uses you have for computers. We like to use Excel, and in Excel we end up using a program called Solver. It's a free add-in. We like to use that instead of very, very expensive specialized programs. And to be perfectly honest, for almost everything you would want to do on your own, any type of decision model you'd want to do on your own, Solver and Excel are plenty powerful enough to make that happen. If you need something more complex than that, you'll probably need somebody who is specially trained with a specialized expensive software package. Kind of like statistics. If you're doing simple business statistics, you do them yourself. That's what we teach you in the business college. For more complex issues, what would you do? You would go out and get a real statistician, all right? So, what are the basics of decision modeling? Number one, a model will represent reality. It's not exact, but it represents it kind of, sort of. It makes it a viable representation of reality. It provides clear recommendations. It tells you, based on the data you have input, based on, remember we talked about decision analysis, we talked about using all the data available at this point in time. Using your data, it gives you a recommendation on what you should do. It saves time and money. It saves time and money in cutting back on the number of calculations you do by hand. It saves time and money because with the clear recommendations, you can eliminate some issues, some problems, some options that aren't as viable. And it could be the only reasonable way to solve for a very complex bunch of equations, again, as opposed to doing it by hand. So what steps do we have in decision modeling? We have basically three main things we're trying to do here. The first is we need to formulate. We need to formulate a model. We put this together. The second thing we do is we come up with a solution. Once we have our formulation, will give us our model that we build from. We then develop our solution from our formula. Then we need to interpret. There are several steps to each one of these. In formulation, we do three things. The first thing we do is define the problem. We talked about this in our decision analysis section. You need to know what you're addressing in order to figure out what kind of a model you're building. The second thing we do is develop our model in order to support this problem that we've defined. The third thing we do then is we acquire data to go into our model. For the solution, the first thing, of course, is we develop our solution. Then we test the solution. Now, when I say test the solution, what do I mean? Does it make sense? Does it follow on? Does it actually make sense what you're getting? Does it make sense according to what you thought you would get? If it doesn't, does the data make sense? Did you get the right data? Did you build the right model? If you get something that makes absolutely no sense at all, you don't run with it. We go back and test our solution. Does it make sense? Does it follow? Interpret. In this case, we analyze. We analyze the solution. And it's a lot like testing the solution. Analyze it. Does it follow? Does it make sense? Is it feasible? Can we actually do this? I mean, if your solution says that the only way to do it is to beam particles across the nation, there's no technology for that, so it doesn't make any sense. How sensitive is your answer to changes in the market? If I go with this solution, if I decide to invest millions upon millions of dollars to implement this solution, how sensitive is it to changes in the market? If I do this and then one thing changes just a small bit, does it make this whole thing outmoded? Does it ruin the whole thing? And then the last one is to implement your solution. Now, what does all of this mean? All right. Up here, we're developing our model. All right, so we've broken this down into 3 main steps. We've got to put our model together. Part of our model, define the problem, put the model itself together, and then go get data to support your model. Once we've done that, we run the model and we get a solution. All right? So we run the model, we get our solution, that's our development here, then we test it. Does it make sense? Did we have errors in our model? Interpret, analyze. Does this make sense? Is it feasible? Is it doable? Will management support it? Part of the analysis needs to be, okay, if this makes sense, will we be allowed to do it? What if we wanted to cut down on the amount of money that the government spends, that the military spends on its senior members up at the Pentagon? What if the solution says, well, one of the problems we have is we have them all living in the high rent district around DC. We're on a very expensive real estate. It costs us a lot of money to stay right there. It'd be cheaper to move the whole thing to Nebraska. Well, that's probably the right answer. It's probably going to cut costs quite a bit. Is it practical? Does the president and the staff want, and the cabinet want all the big key decision makers on the military in the middle of the country when they're out in the DC area? Probably not. So analyze it. Is it doable? Sensitivity we've talked about, and we'll show you how to calculate that. Implementing it. Can you implement it? Is it doable? All right? This is sometimes the most difficult part. Sometimes defining the problem is the most difficult part. Sometimes implementing it. You might have the solution, but it doesn't meet what key members of staff want to do, so you're not allowed to implement it. In every step of this, you will also have to face the possibility of iterations, reiterations. I get down here and I test the solution and it doesn't make sense. Now I have to go back up here and look at my model. Did I build it properly? Or I have to come back up here and look at the data. Did I properly assemble data? We may even have to go back and say, hey, did I define the problem properly? And it can happen, that reiteration can happen anywhere in here. You might get down here to the analysis phase and say, this isn't what we thought, and when you analyze it, you find out, I didn't define the problem right to begin with, and I have to start over. It's not atypical to see that happen. But all of these things have to be looked at when you're developing your model. We'll go into model properties in our next section.